Chadwick Helmuth, the world leader in dynamic balance equipment, introduces the Vibrex 2000, a state-of-the-art propeller and helicopter balancer and analyzer. It's portable, it's rugged, it's reliable, and it's accurate and fast.
It's accurate and fast. I usually count on a balance prop and one set of adjustments.
The importance of propeller balance was recognized early in aviation. There is no difference in the static balance of propellers of yesterday and today. Dynamic balance, however, is a comparatively new development, creating increased safety, comfort, and utility for propeller-driven aircraft and rotorcraft worldwide. A dynamically balanced propeller decreases vibration, enhances comfort, reduces noise, increases safety by reducing component stress, and lowers operating costs. The Vibrex 2000 offers a reliable, profitable service for FBOs and lowers maintenance costs for operators. Enjoy the benefits of dynamic balance and fly with confidence with the Vibrex 2000. All new and overhauled propellers are statically balanced. This method uses gravity to determine the heavy spot on the propeller. During build-up and installation, there can be considerable weight stack-up errors, which result in out-of-balance conditions. The Vibrex 2000 is a tool used to analyze and correct out-of-balance conditions on propellers and rotors on the aircraft, with the propeller or rotor in its operating environment. Let's look at the Vibrex 2000 kit in detail.
The Vibrex 2000 is a tool for helicopter rotor track and balance. Both main rotor and tail rotors, shafts and blowers may be balanced using the Vibrex 2000. For balance of main rotors, a magnetic pickup bracket and magnetic pickup is mounted on the main rotor fixed swash plate. An interrupter is mounted on the rotating swash plate. When the interrupter passes in close proximity to the magnetic pickup, a pulse is generated that is used by the Strobex tracker for tip target illumination and for the balancer in determining phase of imbalance. A lateral sensor is mounted near the roof of the helicopter and measures out of balance of the main rotor. Tip targets are placed on the blade tips for blade tracking. They will be illuminated with the Strobex while the aircraft is running. A vertical sensor is typically mounted on the console, oriented vertically to measure vibration produced by an out-of-track rotor. The cables from the main rotor magnetic pickup, lateral and vertical velocimeter are routed to the instrument in a safe manner, clear of moving parts and controls. The Strobex is attached to the Vibrex 2000 via cable 13797. This cable is then attached to the Strobex 135M-12 and aircraft 12 or 28 VDC supply. The Strobex will operate on a charging 12 VDC bus, that is, one with more than 12.5 volts DC. With the helicopter running, a visual track is performed, and vibration readings are taken at selected flight conditions. Now it is time to measure your track and balance.
From the main menu, press Track and Balance. Select the Strobex track in the next screen. Select the number of blades using the number of blades context key. With the blade spread on, the spread factor key is enabled. A higher number for spread factor increases the horizontal spacing for easier viewing. To take a main rotor balance reading, establish the RPM and flight condition where the balance is to be taken. Then select the desired channel. While taking a reading on the main rotor, it is important to note what flight condition the reading was taken, because several readings may be taken for any sensor during a single flight. To annotate the measurement, press the Annotate context key, enter the selected annotation, press Start. The annotation appears adjacent to the Annotate context key. Press Start, and the balance measurement is saved. To solve for the main rotor, use the balance chart for that aircraft. The balance charts are unique to each aircraft type and the rotor for that type as well. Plot a point at the intersection of clock angle and IPS. 0.99 at 12:06. Plot to the heavy borders of the chart parallel to the fine lines on the graph.
The tail rotor may be tracked with the Vibrex 2000. Tail rotors should always be tracked before they are balanced. Many tail rotors have fixed pitch change links, and there is no adjustment provided for tail rotor track. Nevertheless, tail rotor track may be checked, and should be if there are problems achieving tail rotor balance. Find a convenient location to mount the photocell where it will illuminate the hub. Connect the Vibrex 2000 to the photocell using the photocell cable.
Rotate the tail rotor in line with the photocell beam. Position a retroreflective target in the beam so that the arc the target travels through is tangent to the radius at which it's placed, usually a chordwise direction. The tape is in good alignment when the photocell LED is pulsing. The velocimeter may be mounted but is not necessary for tracking. Install 2 reflective targets on the tail rotor tips. One along the chord line and another across the chord line of the blades. It may be necessary to trim a piece of tape to make them fine enough to fit the blade tips and provide the degree of accuracy needed. Attach and route the photocell cable on the tail boom to the root of the tail boom on the tail rotor side. Connect the Strobex 135M12 to the Vibrex 2000 using adapter cable 13797. Attach the other end of the cable to the aircraft's 12-volt DC. Operate the helicopter at the desired RPM. Observe the blade tips from the root of the tail boom by selecting Strobex Track in the balancer menu. If the rotor has 2 blades, selecting 4 blades will offer twice the number of angles for viewing and make tracking more convenient. Use the Spread Off feature for tracking tail rotors.
Out of track will be shown in the obvious sense. A plus image is a perfect track. Adjust the tail rotor pitch change rods to achieve this picture. Tail rotors are balanced using the photocell, velocimeter, aircraft tail rotor balance chart, and the rotor protractor. Install the velocimeter as shown in the tail rotor balance chart for that specific aircraft. Install the photocell in any convenient location where the beam will strike the tail rotor. Attach and run the cables into the cabin, taking care to ensure the cables cannot foul in the rotor or any drive components.
Operate the tail rotor in the regime specified on the balance chart. From the main menu, press Track and Balance. Select the channel to which the cables are connected. To determine the necessary adjustment to the rotor, place the rotor protractor over the tail rotor chart using the same direction of rotation as the rotor shown on the chart. This is normally the direction of rotation viewed opposite the output shaft side. 12 o'clock on the chart is referred to as straight up on the aircraft. Rotate the rotor protractor so the photocell eye is at the same azimuth as the rotor when the retroreflective tape is just exiting the photocell beam. Plot the clock reading from the balancer at the clock angle of the rotor protractor. Plot the IPS from the balancer on the appropriate IPS ring on the chart. From the intersection of the clock angle and IPS, plot parallel to the fine lines on the chart to the heavy borders. Read the required changes and apply them to the rotor using the diagram for labeling on the tail rotor chart. Repeat this process until the tail rotor is within manufacturer's limits. For example, suppose the tail rotor chart specified an accelerometer be mounted at the 6 o'clock position. The velocimeter is mounted at 6 o'clock just like the chart specifies. It is convenient to mount the photocell at the same bracket at 6 o'clock. The photocell is powered up and the photocell is illuminated to place the retroreflective tape properly. With the tape in place, the rotor is ready to run. A reading is obtained in the balancer. 0.86 IPS at 8 hours 43 minutes. Using the paper chart and the rotor protractor, the protractor is placed on the chart so the photocell on the protractor is at 6 o'clock, just as found on the rotor. The reading is then plotted at the intersection of the clock angle and IPS from the balancer, but using the protractor angles. The resulting point is plotted to the edges of the chart for the rotor correction. The correction is applied per the diagram on the rotor chart, with the retro target identifying the target blade. The helicopter is now tracked and balanced.
After balance, other vibrations are felt. They can be investigated using the analysis function of the Vibrex 2000. Measurements can be taken by hand-holding or rigidly mounting a velocimeter and acquiring a reading.
Since vibration on aircraft are combinations of the rotational speed of components or components tied to those rotational speeds, spectrum analysis is a means to filter the vibrations into known RPM and IPS values. These RPMs, when compared to known RPMs on the aircraft, will make it clear where to look for trouble instead of using hit or miss techniques or expensive parts replacement. To take a spectrum, press Spectrum Analysis from the main menu. Select the channels from which the spectrum are to be taken using the appropriate context keys. Select an RPM range that includes the RPM of interest. The highest RPM range of 0 to 20,000 RPM is the broadest range and should be used if the RPM of the discrepancy is not known. Operate the aircraft in the regime that is most likely to reproduce the discrepant vibration. Press Start. Annotate the spectrum using the number or letter keys. Press Start to save the spectrum to memory. When viewing or reviewing a spectrum, the 10 highest peaks in the range of interest are shown. By pressing the View Peaks context key, the peaks shown are orders of the magnetic pickup or photocell. If the main rotor mag pickup was chosen in the spectrum setup, the main rotor 3 or third order will also be shown, as will subsequent orders. On reciprocating motors used in most light general aviation aircraft, the most pronounced peaks are ordered from the crankshaft speed. Order analysis is a very easy way to identify vibration peaks on reciprocating motors.
The Vibrex 2000 is capable of functioning with a wide variety of printers and computers.
Select the information desired by using the context keys adjacent to the labels on the screen. Print Prop Runs prints the propeller balance runs and their corrections. Another selection in the propeller balance menu is the logbook entry print. Press Go Back to return to the main menu. Print Balance Measure prints the balance measurements and the selected annotations. Press Go Back to return to the main menu. Print Spectrum prints the list of peaks or orders with their annotation. Press Go Back to return to the main menu. Printing may be done via a portable printer or IBM PC. Due to the large selection of serial printers and computers, it is impossible to address every setup for every device. The parameters that are used to download from the Vibrex 2000 for any serial interface is presented in the Vibrex 2000 user guide, to be used in conjunction with your PC or printer manual. The intent of this video is to answer commonly asked questions about the Vibrex 2000. For more detailed information, consult the Vibrex 2000 User's Manual.
Your Vibrex 2000 is built in the same tradition of excellence that you've come to expect from Chadwick Helmuth.